A little bit warmer, that is 75. So some key design things. This data center was designed from the ground up to be showcase more sustainability for HP. HP Labs was involved from day one with that design. I'm part of the Sustainable Data Center project at HP Labs. We built our first full-scale demonstrator in Bangalore, India. That is a 70,000 square foot data center, about the same power as this one. And that was our first instantiation of dynamic smart cooling. When we first turned it on in Bangalore, we dropped the blower power from the cracks by 40%, actually 39. And the overall impact on the data center power for the cooling infrastructure was on the order of 24%. And in India, most of the data centers run on diesel generators because the grid is not particularly reliable there. So when you start talking about savings like that, those are thousands of liters of diesel fuel that you save every year. At the end of the first year, the manager there would not turn off the experiment. Now, admittedly, our demonstrators are better than duct tape and baling wire, but the impact on his budget was so big that he could not afford to turn it off, and it's still running there. So that was the incentive to get us involved in this project, and we did quite a few things. One of the more interesting things, when you build a data center, you have to design it for the location where it is. Here in Colorado, we sort of assumed right up front it would be a gimme for outside air cooling. Now, this is Colorado. Sometimes we have high temperatures with minus signs. It should be easy. Well, it turns out it's not that easy because this is Colorado, and we also have hot days here, sometimes in the hundreds. And what that means is that you have to have a complete redundant cooling infrastructure for your data center, and that doubles the cost roughly to provide cooling. But also, so what we ended up doing is using water-side economizers, basically giant evaporative coolers. And those work because of the dry air here. They work extremely well. So it turned out the most valuable asset that Colorado has is not its cold air, but it's dry air. And then we have that backed up with chillers. We're going to visit all of this stuff today as we go through. And so the chillers alone can supply all the cooling needs for the data center if it turns out to be very hot and humid, so that the evaporative coolers don't work well. The downside of evaporative coolers is that they use a lot of water for two purposes primarily. One is blowdown, where you actually just dump water as it concentrates dirt and stuff like that, just to keep it fresh enough to go into the sanitary sewer. The other, of course, is through evaporation, and that's also a big loss. And Colorado is semi-arid country, so we wanted to be able to evaluate the trade-offs between water and electricity for cooling. So the sandbox in here does have outside air cooling. So we'll visit that as well. So some key things you want to notice. All of the infrastructure is overhead. The power comes in through the Starline bus rails and drops down into the racks. All of the networking is also overhead. And what that means is that what's under the floor is just about nothing. So you have a 30-inch air plenum under there that is completely unobstructed for a free flow of air. And then, in addition to that, you'll notice the plastic curtains. We have hot aisle containment here. So the plan is that the computer room air conditioners, these big gray boxes you see behind you, chill air, they blow it under the floor, it comes up through the grates, and then the only path to get back is through the rack, because the plastic curtains block any other path. And then it goes up through the grates you see in the ceiling. And the ceiling is basically a big return air plenum, goes back into the crack air intakes where it's chilled again and comes back out. The cracks themselves are operated with chilled water. The chilled water is typically supplied by the evaporative coolers outside, and that's another part that we're going to visit. And finally, the tiles themselves are unique in that we have both regular vented tiles, and then we have adaptive vent tiles that are HP Labs technology from the Sustainable Data Center project. And those we can control remotely from basically anywhere in the world to open or close in response to temperature needs. So that control is all automatic. We're bringing this stuff up gradually now and just starting to implement that. We also monitor temperatures here, and you will see on the front of a lot of these racks you'll notice the flashing blue every 15 seconds. We monitor the temperatures here constantly, 24 hours a day. Every 15 seconds we get a new updated reading, and we also monitor limits so that if any sensor gets a temperature of over 30 degrees Celsius, a lot of people get eaten very quickly. Okay, and then here next to me is part of the electrical infrastructure. Power is fed to the data center at 480 volts, three-phase. Goes into the transformer, which is a big blank box there, where it's transformed to 208 three-phase with a neutral, so we can supply 208 or 120 to any rack. And it's distributed through these panels here. Each of these feeds a single Starline bus rail, and that's 400 amps of power out to the bus rail. So with that, let's move on over here to the sandbox. We'll go left here.
Okay. Just that I can do this and feed a three-phase PDU.
Jeffrey, the coolest thing to see is a dagger row I found. The last row.
Oh, they don't have that.
The last time we were here, they had these streamers that you could see the air turning on and off, because the air turns on and off based on where the cooling is needing.
Yeah,
so you could see the streamers turning on as the air would turn on and off. And they're not there. Yeah, exactly.
Yeah, I don't have that demo running today, but I can show you an adaptive vent valve.
Go in?
Yep.
It's got to show the adaptive.
So these have louvers on the bottom that are controlled by a slow-speed motor in here, and it takes about 100 seconds for it to go from all the way open to all the way closed, or vice versa, and they can all be operated simultaneously. So within 2 minutes, I can open or close every AVT in this data center. You'll note high-density power areas like this, we have one AVT in front of every rack so that we can control it. In lower density areas, we alternate them with ordinary, roughly 30% vent tiles so that you can just modulate slightly. The connection here, this looks like LAN cable, and it actually is, but this is really a serial Modbus connection, and they're just daisy chained together. So at the end of each row, we have a little transducer from Ethernet to Modbus for the control.
Got a commercially available product yet?
No. Okay, and there are a couple of unique things about the sandbox. This was named and literally designed to be sort of a play area for HP Labs. It's kind of a lab within a lab. This, as I said, is the one area that does have outside air cooling. It's also unique in the power density. Most of the lab is at 200 watts per square foot. The sandbox is at 350. So there's a better part of a megawatt right in here. Okay, any questions?
No, I know my lab's a small scale. So how did
Powered over the serial cable then, or?
Yes, and in fact, just one pair is used for signal. The other three are in parallel for power and ground to provide power. And they're parallel just to increase current capacity. If you look at this track over here, the little snowflake here is the chilled water valve opening, which is at 0% right now. We're running on all outside air here today, which you'd pretty much expect.
Yeah. So there's dampers on the roof for someplace to...
Yep, there are big air handlers up on this roof up here. What happens is that the air handlers blow air down, and they're all controlled by VFDs, so we can vary the speed. And it comes down, and up above the ceiling here is a mixing box, and it mixes the outside air with the return air to... Exactly. So we supply it here at 75 degrees. And that's actually we're slightly under right now, 73. Okay, any questions?
How's the power conditioning?
Power is conditioned, actually, we have transient voltage surge suppressors, but beyond that, there is no conditioning. There is no UPS. This is an R&D lab. This is not HP.com. If it goes down, it goes down. But the power here in Fort Collins is actually very good. We have a power station that is owned by 4 Front Range cities where you get all of our power. HP is a sustainable energy customer, so a chunk of that power comes from wind, and it actually works out very well. Okay, we're going to move on now outside. We're going to see the infrastructure for the cooling and power. This is stuff you normally never get to see in a data center. So we're going to visit and turn the pump room where you can see the primary and secondary cooling loops. We're going to see the chiller room. We will move on around. We will see the evaporative coolers outside, and then we'll finish with a stop at the main power plant. And there we bring in 13.2 kilovolts from the outside. And you've been cautioned not to touch anything, but that applies here. If you want to touch something in the power plant, my one rule is you've got to tell me first so I can get it on video and post it on YouTube. Okay, let's go.
I nominate Ray. The son I saw on Facebook.
So here, what would be here is what it was about to be retired when this was commissioned.
First of all, we're going in the right direction.
You want to see the recycling process for the production systems, not here.
And it doesn't, and you don't, because by the time stuff's, well, and it's just tools. Yeah. It's like, well, there's nobody, you know.
That'll work. Okay, on through here. Can you use a ticket? Yeah, I'll take it.
Yeah, name is Q, right? To what?
Right, but
Oh yeah.
those DL35G2s
We'll see.
are
I mean,
the
we're
oldest thing you want to
once the beta comes out, I'll have 3 companies that about
Right.
120 users total.
Okay, what you see right in front of you are the 4 big cooling towers for the data center. That's actually our primary cooling. When we first started up, we didn't even have the chillers installed.